There is a quiet misunderstanding that takes root in the minds of many people as the years accumulate. It whispers that the small changes, the forgotten name, the slower retrieval, the moment of mental fog, are simply the price of growing older. That decline is inevitable. That the brain, like an old machine, gradually winds down until one day it simply doesn't work as well as it used to. This belief is so widespread, so deeply embedded in our cultural understanding of aging, that most people never think to question it. They accept the slow erosion of memory and focus as normal. They adapt to it. They expect it. But what if this expectation itself is part of the problem? What if the brain you have today is not a diminished version of the brain you had decades ago, but something more complex, more adaptable, and more capable of change than anyone ever taught you? The emerging science of the aging mind reveals something far more hopeful than the old story of inevitable decline. It suggests that much of what we call aging in the brain is not fixed at all. It is shaped by choices, by habits, by the daily accumulation of small decisions. And understanding this difference between what is truly inevitable and what is merely common may be one of the most valuable pieces of knowledge a person can carry into later life. You are listening to the Longevity Library, where we archive the wisdom of healthy aging, the wisdom of the aging brain, what science reveals about living well. There is a question worth considering as the years pass. It is not a question about wrinkles or aches or any of the surface changes that accompany growing older. It is a deeper question, one that has occupied philosophers and physicians for centuries. What happens to the mind as time moves forward? Does it inevitably decline, slowly losing its sharpness until memory fades and thinking slows? Or is there another possibility, one that modern science is only now beginning to understand in full? The answer, it turns out, is more hopeful than many people realize. The brain in later life is not simply a diminished version of the younger brain. It is different. Yes, but different does not mean worse. In some important ways, the aging brain has advantages that youth cannot claim. And more importantly, much of what happens to the brain as we age is not fixed or predetermined. The brain remains changeable, adaptable, capable of growth and strengthening well into the 9th decade of life and beyond. This is not wishful thinking or the language of self-help books. It is the conclusion of decades of careful scientific research. Research that has fundamentally changed what neuroscientists believe about the aging mind. The story of how this understanding developed, and what it means for everyday life, is worth exploring in some detail. Part 1. The changing brain. For most of the 20th century, the prevailing view among scientists was that the adult brain was fixed. You were born with a certain number of brain cells. The thinking went, and from early adulthood onward, you simply lost them. Decline was inevitable. The brain could only get worse with time, never better. This view was so firmly established that it was taught as fact in medical schools and neuroscience departments across the world. The problem with this view was that it was wrong. It took a series of careful experiments and a willingness to question established dogma to demonstrate just how wrong it was. In the late 1960s, a researcher named Marion Diamond was working at the University of California, Berkeley. She was interested in whether the environment could affect brain structure, a question that most of her colleagues considered settled. Everyone knew that the adult brain did not change. But Diamond decided to look anyway. She took rats and divided them into two groups. Both groups received adequate food and water. Both were healthy, but their living conditions were dramatically different. One group lived in what Diamond called an enriched environment. Their cages contained toys that were changed regularly. They had many other rats to interact with. They had space to move and explore. It was, in essence, a rat version of a stimulating, engaging world. The other group lived in standard laboratory cages. These were clean and provided for all basic needs, but they were sparse. Limited space, few companions, no toys, no novelty. After a period of time, Diamond examined the brains of both groups. If the adult brain could not change, both groups should have had identical brains. But they did not. The rats from the enriched environment had thicker outer brain layers. The cortex, in specific areas. The visual areas were thicker because they had more to look at. The motor areas were thicker because they moved more. The touch areas were thicker because they had more complex physical interactions. The adult brain had changed. It had grown in response to experience. This was the first clear demonstration of what scientists now call neuroplasticity. The brain is not fixed. It is malleable. It responds to what you do, what you experience, what you learn. And this remains true throughout life. Later research confirmed and extended Diamond's findings. Perhaps the most famous human example comes from studies of London taxi cab drivers. To become a licensed taxi driver in London, candidates must pass a test called the Knowledge. They must memorize the layout of approximately 25,000 streets and thousands of landmarks. The test takes about 4 years to prepare for, and only about half of those who attempt it ultimately succeed. Researchers at University College London scanned the brains of taxi driver candidates before they began studying and again after they either passed or failed. Those who successfully became licensed taxi drivers showed measurable growth in the hippocampus, a brain region critical for memory and spatial navigation. Those who failed showed no such growth. And the successful drivers performed better on memory tests than they had before their training. This is plasticity in action. The brain changed its physical structure in response to learning demands. It grew new capacity because it needed to. For people in later life, this research carries an enormously hopeful message. The brain remains capable of change. It can still grow new connections, strengthen existing ones, and in some regions, even generate new neurons. The old view of inevitable uniform decline has given way to a more nuanced and more encouraging understanding. Part 2. The moving brain. Among all the factors that influence brain health, none is more powerful than physical activity. The evidence for this is remarkably consistent across different types of studies, different populations, and different measures of brain function. Every time you move your body, your brain responds. The response is immediate and involves multiple systems. First, movement triggers the release of neurotransmitters that affect mood. Serotonin, dopamine, noradrenaline, all increase with physical activity. This is why even a short walk can lift your spirits. Why people who exercise regularly report better emotional balance than those who are sedentary. But the effects go deeper than mood. Physical activity also triggers the release of growth factors, proteins that act like fertilizer for brain cells. These growth factors travel through the bloodstream and into the brain, where they support the health of existing neurons and, in some regions, stimulate the growth of new ones. The hippocampus is particularly responsive to these growth factors. This seahorse-shaped structure, located deep in the temporal lobe, is critical for forming new memories and for navigating space. It is also one of only 2 brain regions where new neurons continue to be generated throughout life. Physical activity enhances this process. People who are physically active tend to have larger, healthier hippocampi than those who are not. The prefrontal cortex, the region just behind the forehead, also benefits. This area governs attention, decision-making, personality expression, and social behavior. It is essential for the kind of thinking that allows you to focus on what matters, to ignore distractions, to plan for the future. Regular physical activity strengthens the connections in this region. improving its function. The practical implications are substantial. A study of adults aged 65 and older examined the relationship between walking and dementia risk. Researchers asked participants about their walking habits and then followed them for 6 years. Those who took 3 or more walks per week were 30% less likely to develop dementia during the study period compared to those who walked less frequently. 30% is not a trivial reduction. It is the kind of effect that rivals many pharmaceutical interventions, but without the side effects and with additional benefits for physical health. For people who are already active, more activity appears to produce more benefit. A study of regular exercisers examined what happened when they increased their frequency. Participants were given access to a studio and could exercise as much as 7 times per week. The control group maintained their usual routine of about twice weekly. The results showed that every additional workout produced additional brain benefits. More exercise meant better memory, better attention, better mood. This does not mean everyone needs to become an athlete. The threshold for benefit is surprisingly low. For people who are currently inactive, beginning with 2 or 3 sessions per week of 45 minutes of aerobic activity produces measurable improvements. Aerobic activity simply means getting your heart rate up. Power walking counts. So does swimming, cycling, dancing, or any activity that elevates your heart rate. The immediate effects of a single workout are also worth noting. Even 1 session of aerobic exercise improves mood, sharpens focus, and speeds reaction time. This is why some people choose to exercise before activities that require mental sharpness, whether that is a challenging conversation, a public presentation, or simply a day that demands focus. Part 3. The resting brain. If physical activity is the most powerful positive influence on brain health, sleep may be the most important maintenance activity. The brain does not simply shut down during sleep. It engages in essential processes that cannot happen while you are awake. During deep sleep, the hippocampus replays the experiences of the day. Memories are consolidated, strengthened, and integrated into long-term storage. The information you encountered, the conversations you had, the things you learned, all are processed and filed during sleep. If you shorten your sleep, you interfere with this process. Memories that should be consolidated may fade or become disorganized. Equally important is what happens regarding brain cleansing. Throughout the day, brain cells produce metabolic waste products. This is normal biology. Every cell in your body produces garbage. During sleep, the space between brain cells expands slightly, allowing cerebrospinal fluid to flow through and flush out these metabolites. This system, called the glymphatic system, clears out compounds that would otherwise accumulate and interfere with brain function. When you do not get enough sleep, you build up waste products in your brain. People describe this feeling as brain fog or mental sluggishness. They are describing something real. The brain has not been adequately cleaned. Sleep deprivation severe enough, maintained long enough, can be fatal. In extreme situations, organisms deprived of sleep die. Sleep is that fundamental, yet many people routinely cut sleep short, trading rest for another hour of activity. Over time, this accumulates. The brain does not fully recover from chronic sleep restriction. Function declines. Alcohol's effect on sleep deserves attention. Many people use alcohol to fall asleep faster, and it does have sedative properties. However, alcohol profoundly disrupts sleep architecture. The sleep you get after alcohol is more superficial. Deep sleep is reduced. The restorative stages of sleep are compromised. Even if you sleep the same number of hours, the quality is diminished, and the brain does not receive the same benefits. Part 4. The remembering brain. Memory is not a single thing. It is a collection of systems. each with its own characteristics and each depending on different brain regions. Understanding this helps explain why some memories remain sharp while others fade, and why different people have different patterns of memory strength. The hippocampus forms memories for facts and events. When you remember what you had for breakfast, or recall a conversation from yesterday, or think about a vacation from years ago, you are using your hippocampus. This is the system most people think of when they talk about memory, and it is the system most vulnerable to aging and to diseases like Alzheimer's. Different brain systems handle other types of memory. Motor memory, the kind that allows you to ride a bicycle or play a musical instrument, depends on the striatum, a region involved in movement control. You cannot easily explain how you perform these skills, but you can do them. Working memory, the scratch pad that holds a phone number just long enough to dial it, relies on the prefrontal cortex. Research has identified several factors that make memories more likely to stick. These apply whether you are trying to remember names, appointments, or new information you want to retain. The first factor is repetition. The simplest and most obvious. Repeated exposure to information strengthens the neural connections representing that information. This is why reviewing important information works. Why practice matters. Why going over something multiple times helps embed it in memory. The second factor is association. The hippocampus is fundamentally an associative structure. It connects one thing with another. Your name with your face. Places with events. Husbands with wives. The more associations you create around a piece of information, the more routes you have to access it later. This is why linking new information to things you already know makes it easier to remember. The third factor is novelty. The brain's attention system is designed to notice what is new or different. Familiar things fade into the background because they pose no threat and offer no new information. Novel things grab attention. This is why surprising moments tend to stick in memory. Why unusual experiences are recalled more vividly than routine ones. The fourth factor is emotional resonance. People remember the happiest and saddest moments of their lives with particular clarity. This happens because the amygdala, an almond-shaped structure sitting directly in front of the hippocampus, tags emotionally charged experiences. The amygdala gives the hippocampus a jolt during emotional events, strengthening memory formation. Positive emotions work as well as negative ones. Joy, warmth, interest, all enhance memory. Understanding these factors gives practical tools. If you struggle to remember names, consciously associate the name with something distinctive about the person's appearance. Repeat the name during conversation. Create a novel connection. Engage emotionally with the interaction. These techniques leverage how the brain naturally works. Part 5. The connected brain. Humans are social creatures. This is not a matter of preference or culture. It is biology. The brain evolved in social contexts, and it expects social interaction. Research has demonstrated a clear correlation between the number of social connections a person has and their longevity. This includes not just close friendships, but casual interactions. Saying hello to people you encounter regularly. Chatting with neighbors. Greeting the person who prepares your coffee. More social interaction predicts longer life. For brain health specifically, social connection appears equally important. Studies that have followed people for decades find that the strength of social relationships is among the best predictors of cognitive health in later life. People with rich social networks tend to maintain better cognitive function as they age than those who are isolated. Loneliness, by contrast, damages the brain. Chronic loneliness triggers stress responses. Stress hormones, when elevated continuously, first damage synaptic connections and eventually can kill brain cells. The hippocampus, already vulnerable in aging, is particularly sensitive to stress hormone damage. Loneliness literally can make brain regions smaller over time. This does not mean everyone needs a vast social network. Quality matters more than quantity. But regular, meaningful human interaction appears protective. The brain distinguishes between real human connection and digital interaction. Social media, despite its name, does not provide the same benefits as face-to-face contact. The physiological and neurological responses differ. Screen interaction, even video calls, does not fully substitute for physical presence. There is also something important about the variety of social interactions. Interacting with different people, in different contexts, with different conversational demands, challenges the brain in ways that routine interactions do not. Each new person you meet, each new conversation you have, requires your brain to adapt, to predict, to respond. This is a form of mental exercise. Part 6. The fed brain. The brain is metabolically expensive. It represents only about 2% of body weight, but it consumes approximately 20% of the body's energy. What you feed it matters. Among all dietary patterns studied for brain health, the Mediterranean diet has the strongest evidence base. This does not mean you must eat only Mediterranean food. It means the principles of this diet: whole foods, plant focus, healthy fats, minimal processing, are supported by decades of research. The key word is unprocessed. Colorful vegetables, fruits, legumes, whole grains, fish, olive oil. These form the foundation. Processed foods, those with long ingredient lists and chemical additives, appear less beneficial for brain health. A simple guideline is to ask whether a food would be recognizable to someone from 100 years ago. If the answer is no, it may be worth eating sparingly. Specific components of the diet deserve mention. The healthy fats found in olive oil, nuts, and fish are important for brain structure. The brain is about 60% fat, and the type of fat you consume influences the composition of brain cell membranes. Antioxidants from colorful fruits and vegetables help protect brain cells from oxidative damage. B vitamins from whole grains and legumes support the production of neurotransmitters. Hydration also matters. Even mild dehydration affects cognitive function, particularly attention and memory. The brain has no way to store water. It depends on regular intake. As people age, the sense of thirst may diminish, making it easier to become dehydrated without realizing it. Caffeine deserves a nuanced discussion. It is a stimulant, and people respond differently. For some, moderate consumption improves focus and mental clarity. For others, it causes overstimulation and anxiety. The key is self-observation. Pay attention to how different amounts of coffee affect thinking, sleep, and mood. There is no universal right answer. The right amount is whatever optimizes function without disrupting rest. Part 7. The stressed brain. Anxiety and stress have increased significantly in recent decades. Before the pandemic, researchers already noticed rising levels in students and the general population. The pandemic increased worldwide anxiety levels by approximately 20%. Understanding anxiety requires understanding the stress response. When you perceive a threat, your sympathetic nervous system activates what is often called fight or flight. Heart rate increases. Respiration speeds up. Pupils dilate to take in more visual information. Blood diverts from digestion and reproductive organs toward muscles, preparing you to respond. This system evolved to protect from physical threats like predators. It did not evolve for modern life. But the brain still activates the same response when you worry about finances, when you anticipate a difficult conversation, when you receive unexpected news. The threat system does not distinguish between a physical danger and a social worry. The good news is that you have a counterbalancing system. The parasympathetic nervous system governs rest and digest. It slows heart rate, slows breathing, and directs blood back toward digestion and relaxation. And you can activate it voluntarily through a simple mechanism: breathing. Deep, slow breathing is one of the few autonomic functions you can consciously control that triggers the entire parasympathetic cascade. A few deep breaths can begin to shift the nervous system from fight or flight toward rest and digest. This is why controlled breathing has been used in contemplative traditions for thousands of years. It works. Physical activity also directly reduces anxiety. Even 10 minutes of walking can significantly decrease anxiety levels. This effect is immediate and accessible to almost everyone. There is a perspective shift worth considering regarding difficult emotions: anxiety, sadness, anger. These are not mistakes. They are signals. They focus attention on things that matter. Anxiety about a relationship tells you that relationship is important. Sadness at a loss tells you that you valued what you lost. Anger at injustice tells you that fairness matters. This does not mean embracing debilitating anxiety. Clinical anxiety requires professional attention. But everyday emotions, the normal responses to life's challenges, can be understood as information about what you hold dear. The goal is not to eliminate all difficult feelings, but to regulate them so they inform rather than overwhelm. Part 8. The learning brain. The principle of use it or lose it applies to the brain with particular force. Neurons that do not receive stimulation prune back their connections. The brain invests resources where they are used. If you stop learning, stop challenging yourself, stop encountering novelty, the brain adapts to that lower demand by reducing capacity. Learning does not mean formal education. It means engaging with new material, new skills, new perspectives. It means doing things you have not done before. It means putting yourself in situations where you are not completely competent. The London taxi driver study illustrates this principle. The drivers did not simply maintain their spatial abilities. They grew new capacity because they were engaged in intensive learning over years. Their brains responded to demand. For people in later life, the implication is clear: continuing to learn, to challenge the mind, to encounter novelty, supports brain health. This could mean learning a new language, though it does not have to be that ambitious. It could mean taking up a new hobby, learning to play an instrument, studying a topic you never explored before, engaging with ideas that stretch your thinking. The key is that the learning requires effort. Passive consumption, watching television or scrolling through social media, does not provide the same benefit. The brain needs to work. It needs to form new associations, solve problems, adapt to unfamiliar demands. Part 9. The attentive brain. Attention is the gateway to memory. You cannot remember what you did not notice in the first place. Many memory complaints in later life turn out to be attention complaints. The information never made it into memory because attention was elsewhere. The prefrontal cortex governs attention. It allows you to focus on what matters and ignore what does not. It is also one of the brain regions most responsive to training. Mindfulness meditation has been shown to strengthen prefrontal cortex function. The practice of focusing attention on the present moment, typically the breath, and noticing when the mind wanders and bringing it back, is essentially a workout for attention. Each time you notice wandering and return to focus, you strengthen the neural pathways involved in attention control. Long-term meditators show structural differences in brain regions governing attention. They also perform better on tests of attention and cognitive control. The effect appears to be dose-dependent. More practice produces more benefit. The challenge many people face with meditation is consistency. Finding a form that fits your temperament matters. For some, sitting silently works. For others, Movement-based practices like walking meditation or Tai Chi serve the same function. Still others benefit from ritualistic practices where the sequence of actions provides structure that helps maintain focus. The key is finding a sustainable practice. Brief daily practice often outperforms longer sessions that happen only occasionally. 5 minutes every day is more effective than an hour once a week. Part 10. The technology and the brain. The relationship between technology use and brain health requires balanced consideration. Screens and social media are not inherently harmful. They are tools. Their effects depend on how they are used and what they displace. Social media platforms are designed to be engaging. They use variable reward schedules similar to slot machines. You check and sometimes find something interesting. This intermittent reinforcement makes the behavior compelling. It triggers dopamine release, the same neurotransmitter involved in reward and motivation. The concern is not dopamine itself. Dopamine is a normal part of brain function. The concern is what gets displaced. Hours spent on social media are hours not spent on physical activity, not spent in face-to-face social connection, not spent sleeping, not spent learning new things. If screen time displaces brain-healthy activities, the net effect is negative. For young people, the displacement effects appear particularly significant. The rise in anxiety and depression among adolescents correlates with increased smartphone and social media use. The comparison culture, the constant awareness of what others are doing, the pressure to present a curated image, all contribute to psychological distress that has physiological consequences through stress hormones. For adults, the effects may be less dramatic but still worth attention. If you find yourself unable to be alone with your thoughts, reaching for your phone whenever there is a pause, this may indicate a pattern worth examining. The ability to sit quietly, to let the mind wander, to be present with your own thoughts, is a skill. Like any skill, it atrophies without use. It is also a skill associated with creativity and imagination. Part 11. The protected brain. Several factors consistently harm brain structure and function. Understanding them helps inform choices about what to avoid or minimize. Sedentary behavior leads the list. Physical inactivity deprives the brain of growth factors, reduces blood flow, and accelerates age-related changes. The brain evolved in bodies that move. When movement stops, function suffers. Chronic sleep deprivation prevents memory consolidation and allows metabolic waste to accumulate. Over time, this compounds. The brain does not fully recover from chronic sleep restriction. Smoking damages blood vessels throughout the body, including those supplying the brain. Reduced blood flow means reduced oxygen and nutrients. The effect on brain health is unequivocally negative. Loneliness and social isolation trigger chronic stress responses that damage brain structure. The hippocampus shrinks. Cognitive reserve diminishes. Processed diets, high in refined ingredients and low in nutrients, fail to provide the building blocks the brain needs for maintenance and repair. The brain requires quality fuel. Alcohol, even in moderate amounts, disrupts sleep architecture and may have direct effects on brain structure with long-term use. The relationship between alcohol and brain health is complex, but the trend in research suggests that less is better. Lack of novelty and learning also harms the brain. The principle of use it or lose it applies. Neurons that do not receive stimulation prune back connections. The brain adapts to lower demand by reducing capacity. Part 12. The emotional brain. The most profound emotions teach the most profound lessons. Grief, in particular, reveals something important about human connection. When you lose someone you love deeply, the grief is correspondingly deep. The pain reflects the love. If you did not love, you would not grieve. The depth of grief measures the depth of attachment. This insight transforms how difficult emotions can be understood. They are not problems to be solved. They are signals. They tell you what matters. The anxiety about a relationship tells you that relationship is important. The sadness at a loss tells you that you valued what you lost. The anger at injustice tells you that fairness matters. This perspective does not eliminate pain, but it gives pain meaning. And meaning makes pain bearable in a way that senseless suffering is not. People who have experienced profound loss often report increased empathy for others going through similar experiences. They know what to say because they know what helped them. They are not afraid of others' pain because they have sat with their own. This is a form of wisdom that cannot be gained any other way. Part 13. The Integrated Life. The various factors that support brain health do not operate in isolation. They interact. They amplify each other. A person who exercises regularly sleeps better. A person who sleeps well has more energy for social connection. A person with strong social connections experiences less stress. A person with less stress makes better food choices. The whole is greater than the sum of the parts. This is why lifestyle approaches to brain health are more effective than isolated interventions. Taking a supplement while remaining sedentary and socially isolated will not produce the same benefit as improving multiple areas of life. The brain responds to the overall pattern, not to single inputs. The pattern that emerges from the research is coherent. Move regularly. Sleep sufficiently. Eat unprocessed foods. Stay socially connected. Keep learning. Manage stress. Limit what displaces these healthy activities. None of this requires perfection. It requires direction, a general tendency toward health-supporting choices. The brain rewards this tendency. It grows. It strengthens. It builds reserve. And when challenges come, as they always do, that reserve provides a buffer. The brain that has been cared for can withstand more before showing decline. Part 14. The only brain you have. You have only one brain. It is the most complex structure known, and it is yours for the rest of your life. Every day presents opportunities to strengthen it or to neglect it. The choice is not between dramatic interventions. Small, consistent actions accumulate. Walking regularly. Getting adequate sleep. Maintaining social connections. Eating unprocessed foods. Learning new things. Managing stress through breathing. Limiting screen time in favor of real interaction. These are not expensive interventions. They do not require special equipment or expertise. They require only attention and consistency. The research is clear. The brain remains plastic throughout life. You can grow new connections. You can strengthen existing ones. You can build reserve against future challenges. It is never too late to start. And the longer you maintain healthy habits, the greater the benefit. There is something reassuring in this knowledge. The brain is not a passive victim of time. It responds to what you do. It changes in response to your choices. The power to influence its trajectory. Not completely, not absolutely, but meaningfully, rests in your hands. That is not hype. That is not oversimplification. That is what the evidence shows. And for people in later life, it is among the most hopeful findings in all of modern science. The single most important truth to carry forward from this exploration is simple, but it changes everything. The brain you have tomorrow is not already determined. It is being built today by what you do, what you eat, how you move, who you see, how you rest, and what you ask it to learn. This is not a promise of perfection or a guarantee against difficulty. Life brings challenges, and no amount of careful living can prevent all of them. But the evidence is now overwhelming that the trajectory of the aging brain is not fixed. It bends in response to attention. It strengthens with use. It adapts to demand. If this conversation has sparked something in you, a curiosity, a question, a recognition, we invite you to share your thoughts in the comments. What surprised you? What might you do differently? What wisdom from your own experience could you offer to others walking this same path? The Longevity Library exists as a gathering place for exactly these kinds of reflections, a collection of knowledge and experience that grows richer with each voice added. If you have not already, consider subscribing so that new wisdom finds its way to you. And until we meet again in another chapter of this library, remember that every day offers another chance to build a brain that serves you well. This is the Longevity Library. Listen, learn, and live longer.